800 MIPS of floating point performance enable designers to develop low latency systems for computationally demanding control applications. The next, I talked about power when it comes to wearable devices. And we've got an example of one of those devices up here right now. It's the BQ25570. It's a boost charger with integrated buck converter that maintains the industry's lowest levels of active quiescent current and enables battery-free operation for wireless sensor networks, monitor systems, and wearable medical devices. And finally, a product out of my shop, it's the OPA 192. It's an op amp, the industry's first 36-volt rail-to-rail input and output op amp to achieve precision offset voltage and drift without using auto-zero techniques. So in addition to this, when we released this product, we also released 4 of what we call TI designs. These are reference designs that have the complete schematic, they have a complete reference board you can buy, and they all show you how to use these. But we did 2 of these TI designs, which show the different opportunities to leverage the differentiated nature of this product into different end equipments. So in all of these cases, the product innovation that our ICs enable our customers to achieve will help drive creation that will then lead to consumption. If we look at the next slide at TI's commitment to innovation, look back last 5 years, and TI's invested nearly $9 billion in these categories. In the upper corner, our product development is huge. Our product catalog is 100,000 products. We release 900 new cores a year as a company. Highly integrated custom products, software tools, a huge catalog of analog and embedded processing products. So product development has been an area we've invested and spent time. The next area is the R&D labs, our innovation centers focused on high-risk breakthroughs. Our Kilby Labs R&D centers bring together some of our brightest minds to focus on breakthrough ideas. They complement the company's other R&D initiatives by exploring concepts with many unknowns and high risk. And honestly, they explore areas that we would not do in the business of product line or in my shop. So Kilby Labs is one of these. So we started with Kilby opening in Dallas, Texas. Then we opened Kilby Labs in India in 2010. And this was the first Kilby Labs we've opened outside the United States, and it's opened here in Bangalore. Another area here with the R&D labs is technology-specific labs. Examples of this in India are our Power Lab and our Embedded Processing Lab located here in Bangalore, which enable us to co-innovate with customers. We also have a testing and verification lab run by our R&D teams with an Eagle Tester lab run by our Power Management R&D team here in Bangalore. So another category here is manufacturing technology. This has truly differentiated TI from our competitors by having differentiated process and packaging technologies in fabs and assembly and test facilities that we own and control. So having a flexible CMOS development model is key. And then finally, the university and industry. R&D partnerships with leading universities worldwide. TI has many, many universities across the world that are classified as lead universities. TI closely works with these lead universities to develop technologies based on TI devices. The Indian Institute of Science in Bangalore is a TI lead university. We also work with the Indian Institute of Technology on medical electronics technologies. So, and the other part of this is the industry consortia and our engagement. So since expanding our worldwide presence into India in 1985, TI has had a strong and fruitful association with leading industry bodies here. One example is that our engineers actively participate and present technical papers in national and international conferences held across the country. So as we look here at what we do, helping customers do more of analog and embedded processing technology, it's really driven by a couple things, main things. The broad and the deep product portfolio. Having all these products in our portfolio, 100,000 at the TI level. At my level, I have close to 20,000 in my portfolio. And then it's also the systems expertise and the technical support. with TI being able to not only have web-based tools that help our customers utilize our products, but also having local sales and application support near the customers to help you directly where you need it, when you need it. And it's not only with the sales and applications, but my design teams are spread out all over the world too. 20% of my designers are based here in Bangalore. So and I have a very large group of designers worldwide, but this is the second biggest location for me outside of Texas. So India is a large and key market for TI, and we have a big team here. TI's investments in product development, tools, support, R&D, and manufacturing will help strengthen India's electronics, semiconductor ecosystem in areas like power, analog signal chain, and embedded processing. Okay. Questions?
Steve, thanks for the talk. This is John Kent from KLA.
Hi.
One of the things that's being talked about here is the selection potentially of a fab in India and the IP that goes along with it. You live in a world where your fab IP has to last for many years. How do you guys maintain the institutional memory of your IP as designers come and go over a 5-10 year period?
Yeah, I think what you find, especially in my business, that our designers have long lives, and the tribal knowledge is very deep and very thick. We have a very good, aggressive college recruiting system. But what we've been very successful is pairing up those new college grads with some of our veterans, and being able to pass that knowledge down, working very closely with our, we have a TI Tech Ladder is a very well thought of, very difficult place to join, and having these Tech Ladder mentors, working with our, our younger, inexperienced engineers and working them through it, we find that process is able to move down. And by us owning these fabs, having our own internal fabs, we can control, the IP directly into that fab. And because this is global, I have design centers all over the world. It's not out of the question that I would have a German engineer coming down to work with the team in Bangalore, or a TI fellow coming out of Bangalore coming to work with us in Dallas. So we can very easily move and share across design centers, and the flexibility allows us to pass that knowledge and continue to pass it. Our life cycle, I talked about it in my presentation about long life cycles. I just had an op amp that just reached its maximum revenue for any 1 year, and it reached it in its 21st year of life. So this is a 21-year-old op amp that who would have thought 21 years ago it would, and it was selling pretty good, but it sold great last year in its 21st year. So, we have those kind of things, and that we're very aware. And if you look at our acquisitions across the history of TI, picking up true analog companies like Burr Brown, which has a long history of analog design, innovation, and the facility and the Burr Brown engineers are still out in Arizona. I go and see them every month, and they're part of my business. So we have this, we try to encourage, and we motivate, and we keep challenging our engineers. And part of the process is, pairing up the younger with the newer, and with the older, and trying to pass that knowledge along. So it's a good question.
You said there is such a large variety of products here, close to about 100,000. Now, when these, and especially these are also very long term, how does the supply work? The demand may come at any point of time. Do you maintain inventories, or these are orders against, manufacturing against orders? It must be a pretty complex process.
Yeah, it is. I mean, so we also run an inventory program where I can actually create die stock for, say, an ultra low volume product. It's not uncommon for me to have a product that maybe only sells 1,000 units a year. And, but when you have enough of those, it really does add up. So we have to have a way to be able to not shut down the factory if I need to make one wafer of one product. So what we do is we have die stock, we have a inventory strategy that allows us to address these kind of challenges. If you look at TI today, you're going to see lead times at, majority of our products at less than 8 weeks. So it's through good strategies that we have, and of course you have to have good cycle time in your fab as well for high volume products. It's really a benefit for us in how we position TI, because we want to take advantage of that huge broad portfolio that we have, and we realize that at any given time it's having all these products. It is a challenge, and we want to be able to deliver as quickly as possible. Any other questions?
So I guess you must be also porting processes, products which are as old as 15 to 20 years old. You continually keep on transporting processes, or you maintain the old process itself?
Well, I mean, we're continuing. That 21-year-old op amp runs on a process technology that's a little older. So we continue to have that process technology available for us. And at this point, we've fully optimized the process technology. So we fully understand it. We run it, and certain fabs run certain process technologies, and that kind of strategy allows us to target those process technologies at fabs that are properly equipped to do that. Okay, sure.
Thank you, sir, for your keynote address. At this juncture, the first session after the lunch break was indeed very interesting. So before we leave you, I would request Mr. P.V.G. Menon, the president of IESA and the convener of the Vision Summit 2014, to come over and give a memento as a token of love and affection. Ladies and gentlemen, put your hands together for Mr. Anderson. Thank you very much, Mr. Steve Anderson.